This is the second question. So we have this signal of 33 millivolt sine 2 pi 15t, which is the desired signal, and the 100 millivolt sine 2 pi 60, which is the noise. And it has a Butterworth low pass filter with a -3 decibel frequency of 20 Hertz. So the question A is, what order of filter do we need to reduce the noise down to 80 millivolt sine 2 pi 60t? So we have noticed that from 100 millivolt to 80 millivolt, which means the gain of gain is, so the output over input, so 80 millivolt over 100 is 0.18, and that is equal to, if you do the 20 log to the base of 10, 0.18 is going to be -15 decibel. So that's what we want. And what we can do to figure out what order filter do we need is through this equation from the Butterworth filter. And we have this equation over here where, so this is 1 over this Bn omega, so that is the magnitude of the low pass filter. And then we have this equation on the right side with a omega representing the input frequency and the omega naught representing 1 in this case. So this was assuming that the corner frequency is 1. So, and those are and those to the power of 2n, where n represent the order of the filter. And we can rearrange this equation to solve for n. And if we're to do that, we get n equal ln so this is what we get. And for here, if we put all the numbers for this question, so 60, 20, and because if you see the equation, they are actually, we're just interested in the ratio of this input frequency and the corner frequency. So it doesn't have to be changed into radian per second as omega represent, as we can use input just hertz frequency, and since we are just interested in the ratio, it won't matter. So we're just using hertz in this case for our unit. And so that's what we just put over here. And then if you solve this out, you will get 1.5. And so we round it up, and it will give us that we need a second order to do so, to make 80 millivolt sine 2 pi 60. And the second part of the question, it is the magnitude of the signal, and it is also the same principle. So magnitude of the signal, it's just the same equation, and now we don't even need to solve for, and you don't need to modify anymore. We just directly use this equation. So it will be, the gain will be equal to 1 over 1 plus 15 over 20. So 15 from here, input frequency, and the 20 is because we have Butterworth filter that has a corner frequency of 20. And since we're using a second order low pass filter, we are going to put 2n, so 2 times 2, which is 4. So that's why we have 4. We are putting 4 over here. And if you solve it out, we'll get 1 over 1, 1.15 over 1, which is 0.87. And so that's the gain. So if you were to multiply this gain by the input of 33 millivolt, we should get we get 28.7 millivolt sine 28.7 millivolt would be our magnitude.